All right, hey, AP biology students, let's go over the answer to review question number 2. And I think this is a great review question because it forces us to do some things we haven't done a lot of, and that's to use the solute potential equation to answer a question, and then to be able to read a graph to answer another question. So we have this situation where we have dropped a potato into these different sucrose concentrations to see, or a cell, I should say, not a potato, to see what the sucrose concentration of the cell is. And you can see the concentrations that we drop these cells in go all the way from 0 to 1.0. And then you can see a change in mass, and that's a percentage. And it starts positive in that those cells gain water for the lower concentrations, and then they start to lose water as we increase in concentration. So this is not really a part of the question. You can say, just by looking at these numbers, that 0 and 0.2, those concentrations would be considered hypotonic solutions in this situation because the cells gain mass. 0.4 through 1.0, those would be considered hypertonic solutions because the cells lost water, they lost mass. So a little review for hypertonic and hypotonic. And really what the first question is asking, from the data in the graph, determine the molar concentration of the cell. That is really asking, secondarily, what is isotonic? What concentration of sucrose is isotonic with these cells? And it's a lot easier than it appears in the end, because all you have to do is look at the graph to see where there is a 0% change in mass. And the maker of the graph made it pretty simple in that it appears that the molar concentration of the cell is 0.4. So that's the answer to the first question. 0.4, really, molarity, in this case, which you learned about in chemistry. The second question is a little more difficult in that you have to calculate the water potential. And to do that, I gave you two equations, and you had to figure out what equation to use. And there's enough information now in this problem to be able to use this equation, the solute potential equation. So you have the psi Greek letter, which is solute potential, and that's psi subscript s, or psi sub s. That's solute potential, and that's what we want to solve for. So that's our unknown. Now, negative I. What is that? And really what negative I is, or just I itself, would be the number of ions. So in this case, sucrose is not an ionic compound. It is just sucrose, I believe C11H22O11. So because it's just one molecule or one particle, your I for that would be a 1, which obviously will end up becoming negative 1. Now if we use sodium chloride in solution breaks up into 2 ions. So if you see sodium chloride in the future on the AP tests, it would get an I number of 2. The Na plus would be 1, and the Cl minus would be the second one, so it would be 2. C is the molarity or the concentration. I'll just put concentration. And in this case, that comes from our graph, 0.4. R, I should probably have given to you ahead of time, and it will always be given to you. It's a constant, and it's a constant that will be given to you on the AP test. It's always 0.0821, the same R constant that was used for the ideal gas law in chemistry for PV equals nRT. And then T is temperature. And in this case, the temperature you can see is below the graph, 18 degrees Celsius. However, if you remember, you cannot use Celsius or Fahrenheit for equations like this because Celsius and Fahrenheit can give you negative numbers, and we don't want any negative numbers. So the scale you must use is the Kelvin scale, which you will add 273 to your Celsius to get a 291 Kelvin. And now we can plug and chug by saying that we have a -1 times a 0.4 times our constant, 0.0821, times our temperature, and that will give us a final answer of -9.67. In this case, the unit factor will be bars, which would just be a solute potential pressure. So -9.67 bars, final answer for part 2. And like I said, a great question to understand, to go over before the AP test, because we really did not do a math problem like this throughout the year. So hopefully that explains it all. And in the end, this answer just tells you what the solute potential of these cells would be. So hopefully that explains a lot to you, and y'all have a good day. Talk to you later.